Okay, let's start section 10.3. Applying properties of chords. A chord, remember, a chord is a segment with endpoints on a circle. Because its endpoints lie on the circle, any chord divides the circle into two arcs. A diameter divides a circle into two semicircles. Semicircle is 180 degrees. Any other chord divides a circle into a minor arc and a major arc. Here's our theorem. Theorem 10.3. In the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent, which means if this chord is congruent to this chord, then that arc is congruent to that arc. Example 1. In the diagram, circle P is congruent to circle Q. Segment FG is congruent to segment JK. And the measurement of arc JK is 80. Find the measurement of arc FG. Since chord JK is congruent to chord FG, then you can say the measurement of arc FG is also 80 degrees. Okay, you try. Use the diagram of circle D. If the measurement of arc AB is equal to 110, find the measurement of arc BC. Push pause. Try it on your own. It's very difficult. Just kidding. Yep, it was rocket science. The measurement of arc BC is also 110. You try. Use the diagram of circle D. If the measurement of arc AC is 150, find the measurement of arc AB. This one's just a tad bit more difficult. Not too bad though. Push pause. Alright, so you know AC is 150. So I subtracted that from 360 and got 210. Since chord AB is equal to chord BC, then you can say arc AB is equal to arc BC. Since they're equal, I can take the 210 and divide by 2 and get 105. So arc AB is equal to arc BC. They're 105 degrees each. Bisecting arcs. If arc XY is congruent to arc YZ, which is right here, XY is congruent to YZ, XY, YZ, then the point Y and any line segment array that contains Y bisects arc XYZ. Okay, bisects, cuts it in half. And two more theorems. Theorem 10.4. If one chord is a perpendicular bisector of another chord, then the first chord is diameter. So I have a chord, which is a perpendicular, means it's perpendicular to this chord, and it bisects this chord. So SQ is perpendicular to RT, and it cuts RT into two equal pieces. That's how we know SQ is a diameter. Okay, it's really important. Theorem 10.5. If a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So e.g., if the diameter of a circle is perpendicular to a chord, then the diameter bisects the arc. So this diameter bisected arc FD into arc FG and GD. Okay, I put these on a note card now and you can use them for your homework. Alright, 3 bushes are arranged in a garden shown. Where should you place a sprinkler so that it is the same distance from each bush? You think you're going to have a sprinkler out here somewhere and it's going to shoot water, and it always shoots water with the same radius, and you want to make sure that it gets all of those bushes thoroughly watered. So what do? Well, what we would do is draw a picture of bush A, B, and C, and try to find a point equidistant from each one of those bushes. So I'm going to measure AB, and I'm going to cut it in half. Then I'm going to measure BC, and I'm going to cut it in half. And the lines I'm going to draw are going to be perpendicular. Okay, which I did right there. I cut it in half, half. I drew a perpendicular bisector of each segment that connects the bushes. So really, this right here is equidistant from each bush, and that is where the sprinkler would be. And that's really your answer. So I have a perpendicular bisector of the segments connecting each bush. And where the perpendicular bisector meets is equidistant from all the bushes, and the chord connecting, let me draw that better. The chord is also bisected, so it's equidistant. So the distance here, the sprinkler is going to get all of the bushes equally watered. And you're not going to water past the bushes either, which is nice because you don't want to water things that don't need to be watered. Alright, example 3, using a diameter. Use the diameter of circle E to find the length of AC. Tell what theorem you would use. Okay, we learned that if a diameter is perpendicular to a chord, it bisects the chord. So if AF is 7, you can say that FC is also 7, and the length of chord AC is 7 plus 7, which equals 14. You try. Find the measure of the indicated arc in the diagram. First, we're trying to find arc CD. Here we have a diameter that's perpendicular to a chord, which means the chord is cut into equal pieces, and the arcs are equal pieces. Okay, so use that information to finish the problem. Alright, arc CD is 72 degrees. You try, find the measure of the indicated arc in the diagram. We found that x equals 8, right? Let me double check that. Oh goodness. Yes, x equals 8. So, finish the problem. We want to find what arc DE is and then arc CE. Push pause. Not too bad, right? Alright, last theorem of this section, Theorem 10.6. In the same circle, or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So if you look, I have chord CD and chord AB. They are both equidistant from the center because EF equals EG. Okay, so AB equals CD only if EF equals EG. In the diagram of circle C, QR equals ST equals 16. Find CU. So now that we know that the chords are equal, they are congruent, then we can say they are equidistant from the center of the circle. So in essence, that means 2x equals 5x minus 9. I apologize, that's so small. Subtract 2x from both sides. I get 3x minus 9 equals 0. Add 9 to both sides. So x equals 3. Oh, but find CU. CU is 2x. You always have to read the instructions when you get done. 2x equals 6. Okay, so CU equals 6. You try. In the diagram, in example 4, suppose ST equals 32 and CU equals CV equals 12. Find the given length of QR. Okay, since these are equal, you can assume something about the chords. Push pause. Yeah, that wasn't so difficult, was it? QR equals 32. What is QU? Okay, this is perpendicular to the chord, so it cuts the chord in half. Okay, QU equals half of 32? Yeah, 16. And the radius of circle C. Look, they drew us a little triangle here to help us figure it out. Okay, that's the hypotenuse. Let's erase that because you probably can't see it very well. This is the right angle, so QC is the hypotenuse. So we get 16 squared, 12 squared, QC squared. Let me get a calculator out. (16 squared plus 12 squared and the answer is 20, which is the radius. Good job. Daily homework quiz, page 1, page 2, page 3. Nice work.